go.
Okay, the first thing we'll cover today is heating of the press. Before we start extrusion, the press frame should be very warm. The container should be up to temperature for copper phos alloys 515 C. Including the die should be heated. In this example, there is not a die heater available, so we are using the container to preheat the die before preparation for extrusion on the next job. The stem also should be put into the container before extrusion for approximately 15 to 20 minutes to preheat the stem so that during the extrusion, the stem does not begin to pull heat away from the billet. Once that is completed, we need to preheat the billet and bring it to the press. The press speed should be reduced from the normal running speed for your first billet. Your first billet should be started very slowly to develop heat from friction during the first extrusion. If you put the speed up too high, you may develop extreme pressure and have a possible blowout, particularly if the billet begins to heat from the friction and the billet has not had enough time to soak. So once it's in the container, your die is heated, your container is heated, the press frame is heated, the stem is heated. You start your extrusion at 50% speed. Example, if we know that the job runs at 50 millimeter, we should start the first billet at 25 millimeters per minute. And once the billet is extruded, we can then bring up the speed to operational speed. And that extra heat that's developed from the extrusion in the die will aid in the next startup of the next billet. So the key to start an extrusion is to have the proper billet temperature, the proper container temperature, preheating the stem, preheating the die, and also using the copper-based lubricant on the face of the die. You would swab it on the die just before the extrusion, and this will aid in getting the material to flow to each part of the die. The other main factors to watch is once the press begins to operate, we want to keep an eye on our speed. As the press begins to break through, it will develop enough pressure and you should see this number climb and increase in speed and then become stabilized. The number will never be perfect to that number. It will be in a range back and forth, and that is telling us that the press is trying to maintain this set point. And you can easily see through the quality of the product coming out the die during extrusion, if you see cracks, blisters, or breakage of the wire, it will indicate that the speed is too high for the extrusion, and you either have to reduce the speed or reduce the temperature of the billet. Both of those factors will affect what you get out of the die. Once the process has been stabilized and you begin to see a more stable speed, as you extrude more billets, you will develop more frictional temperature in the die. The die temperature will raise each time you extrude a billet to an ambient operating temperature that will be determined by the exchange of heat into the air, what the press basically radiates off, but you develop from friction. As you get into the second or third billet, your process will become very stable because the heat that you're giving off, you will be developing through friction. Here is the main speed control that sends the feedback of the main ram to the closed loop speed control extrusion system. This is a very critical element to maintaining proper speed. It is a cable, it is a self-spring loaded, it should never be touched during extrusion. If you do touch this during extrusion, it will change the speed and the press will react and become, instead of being stable, it will be unstable and your speed will jump all over the place. This is the main key element to maintain speed control during extrusion. And if we go to the pump, this here is our filtration system, and cooling system that cools the hydraulic oil in the reservoir after it's been used for the extrusion process. And during idle periods, oil is always being transferred through this system to maintain oil temperature. This is the pilot system. This system specifically powers the extrusion pump. Its only function is to control the extrusion pump. The extrusion pump is what is the device that controls your extrusion speed during the extrusion and extrusion only. All other movements of the press are controlled by the main hydraulic system. This system will go into a pre-compress mode based on a pressure switch that is mounted here on the pump manifold and is preset to a determined pressure to build your pressure against the billet just before you go into velocity speed control. Once you satisfy the main pressure switch, it will transition to speed control, and this pump will control all extrusion, and all other pumps will be disconnected from extrusion only for container seal and pilot pressure for that system. Once the extrusion is completed, this pump will stop operating, the motor will stay running, and we transition back into the other system that will return the ram automatically to the home position. One of the most important safety factors in extrusion, when you first begin to start a billet for the very first time, never stand directly in front of the platen, stand off to the side. It has been suggested that a light be installed that can be mounted and moved to look into the hole, and a mirror on a handle so you could stand off to the side to see if the wire is flowing out the die ports. Never stand in front of the press, never stand in front of the platen, and everything should be clear in front of the press when you begin an extrusion. Every morning at the start of extrusion, before we start the press and begin extrusion, we should lubricate the machine on a daily basis. The lubrication pump is filled with whey oil that is used to lubricate all the sliding parts of this press. So first thing every day in the morning, we should pull this lever out to load it and pump it 3 times till it stops. And then we should release and let the oil out to the ways. And we should do this 3 times every morning. This assures that we have enough lubrication on the ways for the daily work that this press will be operating in under the conditions. To be sure that we don't begin premature wear of the guides, any of the wear plates, or any of the shoes that support the container, or the main ram from its operation back and forth every day. The main operating control station contains all the elements to operate the press in manual or automatic mode. The first element that is the most important before extrusion is our container seal. The container should be sealed at all times during extrusion. It will be permanently interlocked so that an automatic extrusion cannot be performed unless the container is sealed. There will be a new pressure gauge installed here, although there is one here from the previous system that's still operational. There will be a new one installed to indicate main ram pressure during extrusion. And the operator interface is simply the device that you enter your speed, and it will track it. You have a billet counter that will count how many billets you run, and you have an alarm. If anything goes wrong, we'll signal you what the problem may be if it's a pump failure. And you have your manual controls and your automatic controls, which consist here. So your main pumps are started first, then you start your new pumps for the extrusion, and at approximately 10 seconds the light will come on after all pumps are ready, and then the press is ready to operate. And this button here is what starts your auto cycle. So once the press is prepared, Everything has been heated. You have a billet. You turn this switch to automatic. You press the button, and the press will start an automatic extrusion from the home position. If in the middle of extrusion you need to stop in case of a wire tangle or any development that may happen where you need to stop the press, it is not necessary to take the press out of automatic mode. You simply use the pause button, put it into the pause mode, the press will decompress, will drop all pressure, and everything will stop while you are still in the automatic mode, and this light will flash to indicate to the operator that you have paused the press. Once you take care of any problems or wire tangle that may have occurred, you can simply come back and take pause and put it back into the run mode, and the cycle will start from anywhere during the extrusion cycle except for when it gets to the very end. So that's it for the UBE press today. I hope this has been educational for all. Thank you very much. Dziękuję.